Hey, it's 1T, and in this video I'll be introducing you to the fundamentals of probability. So I think most people have seen some things with probability, so I'm going to ask you to try to do numbers 1 through 8 here. Do as much as you can and then turn the video on. Alright, let's see how you did. So it says use the spinner to the right to answer the following questions. What's the probability of spinning a 4? Well, there's 4 out of, I guess there's one way to roll a 4 is how I would say that, out of a total of 4 different possible outcomes. That's what we call them. So there's 4 outcomes possible. One of them is getting a 4, and so we have a 1 in 4 chance of spinning a 4. What's the probability of spinning an even number? Now I like to think of it in terms of favorable divided by total outcomes. So the number of favorable outcomes, that's getting an even number. Well, there's 2 outcomes that are even, and the total number of outcomes is 4, and so you should have gotten 1/2 there. What's the probability of spinning a 5? Well, there are no 5s of our 4 outcomes, so 0 out of 4, which is 0. What's the probability of spinning a number that's less than 5? Well, all of our outcomes, 1, 2, 3, and 4, are less than 5, so that's 4 out of 4, or 1. All right, let's move on down. So use the following words to fill in the blanks below. Let's see how you did. So number 2, in probability, spinning a wheel, rolling a die, flipping a coin. Each of these is referred to as an experiment. In fact, I'm going to go down to the definition of an experiment. It's number 5. An experiment is any occurrence for which the outcome is uncertain. So when you roll, or when you spin that spinner up above, you don't know what you're going to get. The outcome is uncertain. We have an idea. I mean, we're going to get one of 4 numbers, but it's considered uncertain. All right. There's 2 E words, and that's going to be one of the things that we need to do here is understand the difference between what an experiment is and what an event is. I call them the 2 E words. So in probability, the act of spinning a 4, rolling a 1, or flipping heads, see, that's more specific. It's referred to as an event. So flipping the coin is the experiment. Flipping heads is considered an event. In fact, the definition is number 6. In probability, an event is a subset of the outcomes of an experiment. Well, that would be like flipping heads. That's one of the 2 possible outcomes. We consider that a subset. In the example above, 1, 2, 3, and 4 are referred to as outcomes. I've already been using that word. Number 7, probability, I can't talk today, is a measure of how likely an event is to occur. All right, let's move on down. So the set of all possible outcomes in an experiment is called, and actually there was one more here, the sample space. So that's maybe one you haven't seen or didn't remember. The others are more commonly understood and used. Sample space, that's just a set of all possible outcomes. Probabilities can be expressed in what 3 ways? Well, so far we've been using fractions, but we could also change those to decimals or percents. So for most of what we're going to be doing, we'll write them as fractions. There are certain probabilities we're more likely to use decimals, but either of those could be written as a percent. Probabilities have a value between what 2 numbers? Well, we saw this up above. We could be as low as 0 or as high as 1. So between 0 and 1. Let's go ahead and draw a little diagram here. So here's 0, and here's 1. And in the middle, we're at a half. Now we could say 0% here. This would be 100%, because 1 is 100%. And of course, that makes a half 50%. And we could write 5/10. Anything in here is considered less likely than not to happen. Less likely than not to happen. Over here, you have things that are more likely than not to happen. So basically, this is where a fourth is. Here you'd be at 3/4 in that area. But anywhere in this region, you're less than 50% chance of happening. Anything above, it's got greater than 50% chance of happening. The words we use are for 0% or 0, it's impossible. And for 100%, we say that it's certain to happen. And I think that's about it. Let's go down to talk about the different types of probability. There are 3 types of probability. For an empirical probability, the probability of an event occurring is determined by observing how frequently the event occurs. So basically, it's based on data or observation. That's different than what we've been doing. For a theoretical probability, and I'm going to put a star here because these are the ones we will do the most. The probability of an event occurring is determined through a study of the possible outcomes that can occur for a given experiment. So when we roll a die, we know we have 6 possible outcomes. If we want to know the probability of getting a 1, we know there's 1/6 on the die, so we have a 1 in 6 chance. So we consider that basically a study of the possible outcomes, and that's how we determine the probability. The third is what we call subjective probability. And we really won't talk about that one in this chapter, other than I just want to mention it, which is an estimated probability based on experience and or intuition. Now, sometimes people are pretty experienced and pretty capable of giving a pretty good estimated probability. But actually, it's quite often the case that people are not very good at subjective probability. There are some people that I'll give you 2 examples. They're terrified of going on an airplane because they believe if they go on an airplane, that plane is going to crash. They're convinced. When the truth of the matter is, they're so much more likely to crash and die in a car accident. Because we get in cars a lot more than we get in airplanes. And airplanes, for the most part, don't crash very often. Another example would be, there are some people that play the lottery, and they are convinced that someday they're going to hit it big. But when you actually look at the probabilities, they're actually more likely to be struck by lightning than win like $1 million in the probability or in the lottery. All right, so subjective probabilities tend to not be so good. Empirical probabilities are based on data or observation. Theoretical probabilities, we look at the possible outcomes, and that's how we determine probabilities. That's theoretical, which is what we'll be doing the most. All right, let's move on to the next slide, or next page. So we're actually going to find an empirical probability here. So if one person is randomly selected from the population described in the chart, find the probability that the person is a female. Let's see, here's our females. There's a total of 124. So remember, it's number of favorable outcomes divided by total. In this case, there's a total of 124 that are female. That's what we're looking for. That's what's considered favorable, probability the person's female. Out of a total of how many possible outcomes? Well, there's a total of 242 people. And so you get 62 over 121, or 51,000, or hundreds. So with empirical probabilities, we tend to write them in decimal form, but it is possible that you'll have to give a fraction as an answer. Now notice I just used my calculator to go from here to here, although actually this one's pretty easy to do in your head, but you can use your calculator. Find the probability that the person never married. Well, how many people never married? It just says person. It doesn't. Now, if it said men that never married, we'd only have 40. But person never married, there's a total of 74 out of the 242 total people. So 74 out of 242. If you reduce that, you get 37 over 121, and as a decimal, that's 31 hundredths. Describe the meaning of equally likely outcomes. This one's kind of, what you see is what you get. Basically, each outcome is equally likely. This is what we sometimes call a circular reasoning type of argument. But that's all it is each outcome is equally likely. We can look back at that first page, and each of these regions are 90% of the circle, or 90 degrees in the circle. They're equal, so the chance of getting a 1 is just as good as getting a 3. These are equally likely outcomes. Notice in the problem we're going to be doing below, the area for the 1's a lot bigger for 2 and 3, so those are not, getting a 1 and getting a 2, those are not equally likely outcomes. All right, let's move on down to 14. So assuming the outcomes of an experiment are equally likely, the probability of event E occurring, so basically we say the probability of some event E is the number of ways E can occur, that's what I call favorable outcomes, divided by the total number of outcomes, which I just used TOT for total. All right, so this is what you'll see as a definition in the book. Number of ways that E can occur, divided by the total number of outcomes. So P of 6, this just means when you roll a die, the probability of getting a 6. Well, there's 6 possible outcomes. Actually, let me just start a little differently. How about we'll just write favorable over total outcomes. Favorable outcome is getting a 6. Well, there's one of those out of 6 total outcomes, so we have a 1 in 6 chance of getting a 6. You should be able to do the other 4 here and then watch the video and you can see how you did. All right, so even numbers, there's 3 even numbers as possible outcomes when you roll a die out of 6, and so you have a 1 in 2 chance of getting an even number. In fact, aren't half of the numbers even and half of the numbers, our outcomes, are odd? Probability you get a number less than 5, well, that would be 4, 3, 2, 1, so there's 4 possible outcomes, or 4 favorable outcomes where you're getting a number less than 5 out of 6. So here we're going to get 2/3. Probability of getting a 7, it ain't going to happen. There's 0 7s for your 6 outcomes. 0 out of 6 is 0. Probability of getting a positive number. Well, 1 through 6, those are all positive numbers, so all 6 of the outcomes, 6 out of 6 are positive. So the probability is 1. We're certain to get a positive number. All right, let's move on to number 15. In fact, you may want to try these 15, 16, and 17 and then watch the video. All right, let's see how you did. So the probability of getting a 1, be careful here, isn't the 1 area half of the circle? So you have a probability of 1/2 of getting a 1. Now, some people will do this. You can divide this side into 2 and then make this a 1. So there's 2 areas that have 1 out of the 4 equal areas. So we could have said 2 out of 4 then, and that does reduce to a half. But either way, if half the circle is a 1, the probability of getting a 1 is going to be a half. All right, probability of getting a 2, well, that would be 1/4 of the circle, or you have 4 outcomes, 2 of them are 1s, and one of them is getting a 2, so you have a 1 in 4 chance. To get a 3, you have a 1 in 4 chance. It says the sum of the theoretical probabilities of all possible outcomes is, and you should have said 1. Well, these are all the possible outcomes here, 1, 2, and 3. And if you add these probabilities, 1/4 plus 1/4 is 2/4, which is a half, plus another half is 1. I'll give you another example. The probability of getting heads, if you flip a coin, plus the probability of getting tails, that's my only possibilities, heads or tails. So that's going to be 1/2 plus 1/2, and notice we get 1. All right, so if you look at all possible outcomes and you find their probabilities, it will add up to 1. That's when we're dealing with theoretical probabilities. In any experiment, event must occur or not. I think we can agree on that. For example, if you roll a die, you either get a 6 or you don't. Well, what if you wanted to know the probability of getting a 6 plus the probability of not getting a 6? Well, on a die, there's only 1 6, so you have a 1 in 6 chance of getting a 6. Well, there's 5 numbers that are not a 6, so you have a 5 in 6 chance of not getting a 6. And notice those do add up to 1. So the probability that something will occur plus the probability that it won't occur is always going to be 1. All right, let's go ahead and move on to the next slide. In fact, you know what? I think I'm going to stop right here and I'll make a second video. So that's it for this one.